Hello, my name is Davis Binger, and let's talk about the ratio test. Today we will be looking at problem 7 of the 9.5 handout. We will consider the series, the sum from k equals 0 to infinity of negative 3 to the k times k plus 4 to the 30th power divided by k factorial. We will then determine whether the series converges or diverges and indicate any test we use. Let us recall the ratio test. One evaluates the limit of the ratio of consecutive terms. Then, based on the value of this limit, we can determine convergence, divergence, or if the test itself is inconclusive. If the limit is less than 1 in magnitude, the series converges. If it is larger than 1, the series diverges. If it is equal to 1, the test is inconclusive. We will perform the ratio test on this particular series due to the structure of the series itself. Note that it is a combination of polynomial terms, factorial terms, and geometric terms. This amalgamation suits itself to initial study through the ratio test. Thus, we're interested in the limit of the ratio of terms. So here we have written the k plus first term divided by the k term. Our job will be to simplify this expression and then group like terms for direct comparison. We will multiply through by the reciprocal of k plus 4 to the 30 over k factorial. Then we can combine the k plus 5 to the 30 with the k plus 4 to the 30 in one grouping, and also group the factorial terms. Note that we have simplified the 3 to the k plus 1 over 3 to the k, and this is just 3. We can rewrite k plus 5 to the 30 over k plus 4 to the 30 as k plus 5 over k plus 4 to the 30. And using properties of factorial, k plus 1 factorial is equal to k plus 1 times k factorial. Thus, these k factorials cancel, and the last term is simply 1 over k plus 1. Now we can perform long division with this middle term, and k plus 5 over k plus 4 is equal to 1 plus 1 over k plus 4. As k goes to infinity, the middle term tends to 1 to the 30th power, or just 1, while the 1 over k plus 1 term tends to 0. Thus, the entire ratio tends to 0. Since 0 is less than 1 in magnitude, by the ratio test, the series converges. And we are done with the problem. Thank you for watching, and as always, you can contact me by leaving a comment below or writing me an email at binger@math.ohio-state.edu. Thank you, and have a good evening.